All right, so someone asked me to do an example of P6, number 10. In this problem, it wants you to solve for x and y so that both of these complex numbers are equal to each other. So, the first thing you have to do is simplify both the left and the right side of the equation. To simplify the left, I want to get rid of these parentheses. Well, there's nothing really keeping them there. So then I'm just going to combine like terms. So I have 6 minus 5. So that's going to be 1. Then I still have minus 7i. So that's the right side. Then to do the left, sorry, my voice. You want to get rid of these parentheses. You have to distribute the number in front, which is, remember, there's technically a negative 1. So I'm going to go negative 1 times 7 is negative 7. Negative 1 times yi is negative yi. Remember, with complex numbers, there's both a real, so here's our real number, our real component, an imaginary component. So this is our imaginary component. If we want this to be equal to this, that means our real has to be the same, and our imaginary component has to be the same. So if we look over here, our real component is all of this. This is our real. Our imaginary component is the negative yi. So this is imaginary. So if I want to find what x and y equal, I know my real has to be equal to my real. So that means 1 is equal to x minus 7. Well, if you solve, you'd add 7 to both sides, so you'd get x is equal to 8. Now we're not done because we still need to find y. Well, y is a part of our imaginary component. And over here, our imaginary component's negative 7i. So we know negative 7i has to be equal to negative yi. So then, to solve for y, we divide by negative I. We get y is equal to 7. That's all you have to do. So x would be 8 and y would be 7.